Steve Van Order, AMP EFI, DIYAutoTune, and today we're here with Scott Kaiser, and we're going to talk about his Lotus project. So Scott, why don't you tell us a little bit about what we got going on?
So this is a 2002 Lotus Elise. We did not get the Lotus Elise in the United States till 2005. So this car did come over from Britain. You can see the sticker on the back here from England. The gentleman that owned this car was in the Army and he was able to bring it in legally, but he passed away unfortunately, and no one can register this car until 2006. I think we have one more year, but since it's a track-only car, it's perfect for us. So one of the big differences though with this car versus the ones we got, this rear cross member was way out here on our cars, and then we didn't get these aluminum struts back here. So there were some major changes to the rear end because these cars tended to be a little tail happy, and Lotus being so good at engineering suspension components, they just scrapped this plan and redesigned the whole rear end and really stabilized the car by the time we got them in '05. But it gave some real challenges to do this project because we had to find a company in Britain to make the swap kit because we decided to go with a K24 swap in this car. This motor came from 4-piston and should produce around 320 horsepower naturally aspirated. So it's going to be a fun little car. Also, our cars came in around 1,900 and some odd pounds. I can't remember the exact figure, but these earlier models were around 1,750 pounds. So this thing's going to be weight to power, really dynamic on track. So first thing we did was we stripped all the suspension off the car. We took all the A-arms off, sandblasted them, recoated them all with Steelite. We replaced all the ball joints. We replaced all the pivot points with like Heim joint type. I can't remember what you call them, but instead of the rubber, they have like the Heim joint materials in there. We added the extra support for the toe links. Sorry, couldn't remember the name of it. The toe links got the extra support, the extra bolts here into the frame. A lot of the cars, once they get slicks put on, they would actually break the toe links and you would wreck the car. So almost everybody in the Lotus world, they uprate their toe links. So these are uprated. The other thing we did was we went to a floating rotor setup and we got a front caliper and we put it on the rear. So there's a company in Kansas called BOE, and they recommend this is a really good upgrade because these cars are really biased in the front and the rear is doing almost nothing brake-wise from the factory. My understanding is, don't quote me on this, but I believe the rear calipers on an '05 were from a Dodge Viper, and it was the parking brake that they used for the rear driving brake. So we used the front caliper, and then we used XPS 10s in the front and 8s in the back, so one less compound in the rear to kind of balance the car. According to BOE, it's a perfect setup for the brakes. So on the motor, we decided that we could not fit any Honda intakes in the car. Just would not fit. So we had to make our own intake here. So I think we did a pretty good job making it, but it caused some challenges, and Steve had some recommendations with us making our own intake.
All right, so intake manifold challenges. Anytime you're doing a custom intake manifold, you're gonna, especially if you don't have a flow bench, you don't have anything to make sure that each runner or each cylinder is going to flow the same, get the same amount of air. That does pose a significant problem from a tuning standpoint, sometimes depending on how different the flow is per cylinder. This being a center top entry, especially with the way this is designed, the two outside runners may get less air than the two inside runners. And that's why I suggested adding EGTs to the exhaust. What that's going to allow us to do is take a single O2 reading from the exhaust, and then basically what I'm going to do is, using our AMP EFI EGT box, I am going to balance the EGTs for temperature on all the cylinders. And I can do that through a number of ways. On this project, we're probably going to be using the MS3 Pro Mini. It was specifically designed for the K-Series engine. And I have a number of trim tables in there, so I'll go in and I'll trim the fuel on each cylinder, and then, if necessary, go in and trim the ignition on each cylinder, but that's usually not as important on this type of issue. Some other things we're running on this car is we've got a map sensor, 1/8" NPT screwed directly into the manifold. I like to have redundancy in my system, and I prefer, especially on something that's going to be this aggressive, to take the map reading as close to the throttle as possible. Due to packaging reasons, it's off in the corner on this intake manifold. Nothing wrong with that. We're going to be running fuel injector connection injectors. We do carry those directly on DIYAutoTune.com. We carry a number of injectors that you can order for your project. These, we're probably going to run something in the realm of 80 to 100 pound an hour, or somewhere between 800 to 1,000 cc injectors on this build. So we actually do have a drop-on harness being put together for this engine. Luckily, we have a perfectly good test mule here that we'll be working on that with. Once we have it ready, we'll bring it over, we'll put it on this motor, and we'll give you guys an update about that. So, I mean, beyond what we're going to be doing with, obviously, all the sensors and the engine management, this should be a pretty stout build. I'm pretty excited about this one. I guess give us a tour of the car. Let us show it off a little bit.
So we have done a lot of fabrication to this build so far. One of the things we did was we didn't like how weak these down bars were on the roll cage setup, so we did beef these up. It gave us a chance to mount our cooling system to it. So we fabbed these tanks up, swirl pot and an overflow tank. We did buy a kit, so it came with the lid and the top of the tank, but we had to weld it together. And then we used tabs here to mount our oil cooling as well. Hiding back in here, you probably can't even see it, but there's a fuel surge tank tucked in here to help us not run out of fuel. And then the rest of the roll cage got beefed up here too, or actually it was non-existent, so we added the roll cage. This is another cool thing that a local gentleman that does a lot of fiberglass work, Larry, he does a lot of work on the IMSA cars. He made this he has a Lotus Exige, and he made this piece. So what this does is it allows the cold air scoop to come all the way to the front of the car. And as you can see, it's a T-top. In order to mount the T-top, normally you would have to rotate the clamshell. So he also made this piece. So this piece gets mounted onto here, and now the T-top can fit in this groove, and the rear clamshell can fit in the groove, so you don't have to remove one or the other. You can do one by itself or the other by itself. You can see inside shot of the car there. This is a right-hand drive car, which is pretty neat. Might take a little bit getting used to drive it, but you can see the roll cage down here. We did add a harness bar in the back. And then what we also had Larry do for us is, this is going to be a wide-bodied car. So you could see here where the old, I guess that's a rocker panel, came up. You can see how much wider it is. It's probably about 2 inches wider here. So we had to replace the rocker panels. And then the front here was widened as well for our wide body. You can tell that this piece starts to leave the OEM piece of fiberglass right here. It's probably about 1/4 of an inch there, and then it continues to widen out here for our wide body.
How much wider is the car in total?
It's about 2 inches in the rear and about 1.5 inches in the front,
Total.
Wider.
So you added like 3/4 of an inch in the
On either side. So 3 inches in the front, about 4 in the rear.
Oh wow, that's pretty significant.
And then we did go ahead and delete the headlights. So we just got some carbon inserts here in the headlights. We designed a really neat way to attach this. The book says 4 hours to remove the clamshell. We didn't want to take 4 hours to remove our clamshell if we were on track and needed access to something. So we're only going to have a bolt here and a bolt there. And we made a pin system that will pin directly into the chassis. So you take 2 bolts out and the whole thing slides out of the pins and can be removed. Haven't removed it yet, trying to make a time, but I'm guessing 2 minutes. The whole clamshell will be removed.
That's way better than factory. That top piece that goes up here, you said it's got a cold air feed that comes in. Is that going to feed the intake manifold?
Yeah. Yeah.
Very cool.
Yeah, we're going to have we're going to have an air filter. We're going to have an air filter bolted here. So this will funnel air. It still needs to be cut out a little bit in the rear, so it's not sitting exactly correctly. But once this is all fit correctly, cold air will come through here. It'll go through our air cleaner, bolted to here, and then that will feed right into our intake. So we'll have a box sitting right here. Terrible for visibility, but we are going to have a reverse-looking camera with a screen on the dash. So if we need to see behind us, we'll see it on a screen.
Nice.
Similar to what Tesla's doing
Okay.
with the Cybertrucks. So this is our cold air intake that we made. It's going to sit here on the car, kind of at an angle. The cold air will be fed right into it and then coupled right down there into the intake. This is the rear clam. You can see here where the wide body was grafted on. So this is where we're going to add about 2 inches to the rear. We're trying to do some chassis mounting for this wing. A lot of Lotuses, they just mount them to the fiberglass, and it seems to work okay. But we wanted to do a little bit more. So we've got some aluminum structure underneath these. So it's sandwich bolted to the fiberglass. And then we'll have a crossbar that extends out a little bit further and will come right down and set on these frame rails. So we'll have a ton of downforce can really push down on here and not affect our glass work at all.
So one of the big difficulties with any race car is thermal management. We are officially a supplier of Funk Motorsports products, and that's what we've used here on this this back firewall is some of their gold reflective tape. It's going to get rid of 90% of the heat coming off of the engine. You'll notice this vehicle is going to be outfitted with a lot more Funk products, along with some of our other projects that we have going on in the shop. Keep an eye out on the website for that thermal management if that's something that you're interested in. And then, moving forward, we're going to be adding a lot more to the lineup. Thanks for joining us today. Like, subscribe, let us know what you want to see, what you want to hear. If you've got video ideas for us, let us know. Thank you.